Permutation.
Hello, good day to everyone. Okay, right now I will discuss all about permutation. Permutation is involved in the study of probability. Okay, so it is very nice and good if you know about permutation. Okay, when you are aiming to know more about probabilities. Okay, permutation it refers to the possible arrangement. Yeah, that is not an outcomes, an arrangement of an objects in a certain or specific order. Again, permutation it refers to the possible arrangement of an objects in a certain or specific order. Okay, upon studying permutation, okay, we will go with the word or the concept of n factorial. N factorial has the formula of n times the quantity of n minus 1 and the quantity of n minus 2 times that 2 times 1, and that is n factorial. Okay, and also, okay, aside from this formula of the n factorial, okay, we also have the other cases, okay, in the study of permutation. A formula for the other cases, like a permutation taken all at a time and a permutation taken r at a time. So we go with a permutation taken all at a time. So if that is a permutation taken all at a time, okay, we will use the formula n, capital letter P, permutation n. Npn is equal to n factorial. It's like the formula in the n factorial. Okay, so npn is equal to n factorial. Therefore, if the value of n here is 7, so the n here must be 7. So it's like 7 factorial. Okay, while on the other hand, if the permutation is taken r at a time, so the n is constantly n here, while on the other side it will be an r. So n permutation r is equal to, okay, this is the formula, n factorial all over the quantity of n minus r factorial. So that's the permutation, or that's the formula. Okay, so to have an example, like number 1, evaluate what is 7 factorial. So in 7 factorial, it's, okay, following the formula, okay, n times n minus 1, n minus 2, dot 2 times 1. So 7 factorial in short is you are multiplying, okay, the in a descending way, okay, the next smaller number. So 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, 0 is not included. So 7 times 6 times 5 times 4 times 3 times 2 times 1 only. So will give us 5040. So that's it. Okay, the problem is if you do not know how to multiply. Yeah. What about number 2? 5 factorial plus 2 factorial. Some give an answer of 7 factorial, which is not good, and that's not the right answer. That is wrong. So you need to evaluate first what is 5 factorial, and same with 2 factorial. So 5 factorial, okay, as you look at the calculation here, 5 times 4 is 20, times 3 is 60, times 2 is 120, in here times 1 is 120, so will give us 120. Okay, and while the other hand is, okay, 2 factorial will give us 2 times 1 is 2, so 120 times 120 plus 2, the sum is 122. Okay, for number 3, okay, this is a division, okay, type. Okay, we have the numerator, which is 7 factorial, and denominator 6 factorial. Okay, so what happened? Yeah, 7 times 6 times 5 times 4 times 3 times 2 times 1, all over 6 times 5 times 4 times 3 times 2 times 1. Okay, you can multiply all and it will give you 5040. Same with 6 times 5 going to 1, give you 720, and do some division, will give you 7. Another way is you cross out 6 times 5 going to 1 and 6 times 5 going to 1, you cross out. The remaining number is 7. Therefore, the answer is 7. They are both 7, or they are the same. Okay. Okay, for number 4, okay, a case like a permutation taken all at a time, 7p7 will give n factorial. 7 factorial is 5040. On the other hand, okay, the last example, 3p2 An example of permutation, take an r at a time. N factorial, applying the formula n factorial all over the quantity of n minus r factorial. The n is 3. The n is 3. 3. The quantity 3 minus 2. R is 2. So 3 minus 2 is 1. 1 factorial and 3 factorial. So 3 times 2 times 1 is 6. 1 factorial is 1. So 6. A number divided by 1, the answer is the number like 6 or like 5. So 6 divided by 1 is 6. Okay. Okay, 5 factorial. Okay, so 5 times 4 times 3 times 2 times 1. So 5 times 4. Okay, 5 times 4 is 20. Times 3, 60. Times 2, 120. And times 1, 120. Therefore, 5 factorial has the so-called value of 120. While the 2 factorial has the value of 2. 2 times 1 will give us 2. So 120 plus 2. 120 plus 2 will give us 122. Okay, and that is the sum of 5 factorial plus 2 factorial. Okay, so if in case, okay, so for example, this is example number 1, number 2, and this for number 3. Okay, so for number 3, like 7 factorial divided by 6 factorial. So you need to evaluate 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, times 1. Okay, and the other all over 6 times 5 times 4 times 3 times 2 times 1. Okay, one thing that I can help, okay, one thing that I can help to you, okay, okay, the first or the basic way of calculation, you evaluate 7 times 6 times 5 times 4 times 3 times 2 times 1. That will give you 5040. Okay, then the other one is 6 times 5. Okay, 6 times 5 is 30, times 4 120, times 3 360. Am I right? Okay, 120 times 3 360, and times 2 360 times 2. Okay, 0, 12, and 720, and times 1 720. Okay, the denominator is 720, the numerator is 5040. Okay, now if you divide that 1, okay, it will give you 7. Okay, it's the same with you cross out 6 from 6 times 5 times 4 times 3 times 2 times 1, from the 6 times 5 times 4 times 3 times 2 times 1 of the denominator, and the remaining number is 7. So therefore the answer is 7. They are the same. Okay, so that's the basic calculation involving n factorial. What if, say for example, you have the problem number 4, like 7p7. Okay, the value of n is 7, permutation 7, the n is 7, the n is 7, and the other n is 7. So you must apply the formula that I told you earlier. Okay, so you apply the n factorial. So n factorial will be 7 factorial. So it will give you 5040. Okay, what if, okay, it is the example for a permutation taken r at a time, like, say for example 3p2, the value of n is 3 and the value of r is 2. So you need to apply the formula n factorial all over n minus r factorial. So we'll get the value of n is 3 factorial, then 3 minus, what's the r? 2 factorial. So will give us, okay, 3 times 2 times 1 all over 3 minus 2 will give us 1 factorial. Okay, so therefore 3 times 2 times 1 is 6 all over 1 factorial 1. Therefore the value is 6. Okay, so that's it. Okay, that's how easy is permutation. Okay, again, permutation is included when you are engaged with the probability most of the time, because permutation is all about the arrangement. Okay, it refers to the possible outcomes. It refers to the possible arrangement. Okay, it refers to the possible arrangement of a certain object in a specific order. Okay, so yeah, again, permutation, it refers to the possible arrangement of a given objects in a certain or specific order. Okay, these are the examples. Okay, so that's all. Okay, our discussion for today, it's all about permutation. Okay, remember and take note, guys, that in studying permutation, 0 factorial is equal to 1. And in some study, or in the United States, some of the mathematicians, okay, this certain concept became debatable, okay, because of the value of 0 factorial, which is 1, and the value of 1 factorial, which is 1. Okay, some may say that this is not good. Why? Because 0 in the other hand is not the same with 1. Why 0 factorial becomes 1, and why 1 factorial becomes 1. Okay, so it's understandable if 1 factorial will be 1, but 0 factorial, okay, some of the mathematicians, okay, do not agree with it. Okay, but in the study of, okay, in the standard way of studying about a factorial, 0 factorial has the value of 1. Okay, and 1 factorial has the value of 1. Okay, so that's all for today. Don't forget to like, share, and subscribe for more videos like this.